Hi there. I hope you are doing good and well. So first of all, I would like to thank you for sharing this assignment. So I would happy to resolve it and I demonstrate my approach step by step. So what I understood from the given task that you have given two main things. One is the image sample image to test against, and one is the YOLO model in PyTorch format that we need to use. So in this main two tasks are there. One is to predict the image using the given YOLO model and then convert it into the ONXX model, and then using converted ONXX model to run again the same inference on the same image. So in this task, we need to create a new development, fresh Python virtual development environment for that, and we need to install the all required dependencies and all. So first, we need to inference with the PyTorch model, then convert it into the model of ONNX, and inference with the ONNX model with the same image. So and also this is an optional of IOE comparison between those two PyTorch detection and the ONNX detection. So yeah, we will go through one by one steps. And in this task assignment, I will use the AI assistant or coding partner as Cloud. So as I am more confident and more, I'm using frequently Cloud for the my daily day-to-day life activities. So yeah, we will go with that Cloud as well in this assignment. So from the starting of this, let's create one directory. So right now we are in the client folder where every client's projects are there. So let's create one directory for this yellow test sample. So yeah, the, yeah. Now we will opening the Visual Studio Code here. Yeah. So as you can see, the empty directory over here, nothing else in the that. So we will first start the cloud. So here, just proceed. Okay. So now, before starting or before doing anything, let's understand what Cloud will give us a plan that what we need to achieve today, right? So let's give some idea to the cloud that what we are building today. So let's give it a prompt to the cloud that I need to run, I guess, YOLO inference using .pt model. First, we need to inference using the PT model, then convert it to ONNX model and run inference again on the same image using ONNX model. Can you outline the steps I follow, including the project structure and I think dependencies and all. Dependencies and all. Let's see what Cloud A will give us for this. So basically, we will check how Cloud A is thinking. What is the task that we need to follow for achieving this assignment, right? So first of all, he's checking the directory and permissions of that. Yeah, so you have an empty directory setup. Let me outline it. Okay, so right now he is giving the project structure for this. So he's suggesting in model, we need to put model. Images, we need to put images. Output should be the result which we have converted the object detections of the image. Requirements and also requirement is Ultralytics, OpenCV Python, NumPy, ONNX, ONNX NumPy, Torch, and Pillow. So yeah, these are the dependencies actually we need to detect the object and using PyTorch and the ONNX model. So yeah, so this is the requirement for that. I think it's still thinking the process like task, what we need to follow, I guess. So let's see, let's it complete. Hmm. So yeah, so the workflow is the create project structure. requirement.txt and install dependencies. Add a test image to images folder and run and all. So step one, PyTorch interface, convert to ONNX and ONNX interference. Yeah, so this is our task. So I think he understood that what we need to do. So let's start with the step by step. So first, let's ask him to let's please generate the requirement.txt file based on your plan, which includes the dependencies of which includes required dependencies for this project. Let's see. So basically what we are doing is we are creating one requirement.txt file in which we will yeah. So do you want to make this edit requirements? Yes, allow using this session. So it's created the requirement. So basically this file is context what the dependencies we need to install using Python, and so what are the requirements for this project. Yeah. So here it's mentioned that what particular each dependency is using for. So basically Ultralytics is for main YOLO framework for loading and running PT model. So this is the basic that we need to install. NumPy for Neuralic operations, I guess for IOU comparisons and all. So ONNX is for the ONX conversion and inference. Torch is PyTorch framework for PT model to support. So that is also required. MATLAB pilot, Pillow. I think Pillow and MATLAB, but not required. But let's see what is requirement in future. So let's give an instruction that install all the dependencies into. Okay. Before that, I think let's create one virtual environment and then we will create, I guess, dependencies install. So let's give him a command that let's first create a virtual Python environment and then install all the dependencies. So basically we will creating the virtual environment using Python minus vnv dot vnv. So I think he's running the same command. Yeah, Python v minus m vnv dot vnv. Yes, he is asking the permissions to execute the command. So I have given the yes command. Creating the Python virtual environment. Yes. So now it installing the dependencies. Again, he is asking that do you want to install the dependencies from the requirement.txt? Yes. So now it is installing the project dependencies over here. Yeah. So I think it started to installing all the required dependencies. Let's wait for some time to complete this process. Okay. So I think installed packages, virtual environment is also created. Install packages, whatever the installation has been given into the requirements file. So it is also done. To use virtual environment, use this one to activate the virtual environment. Okay, so now we will activate it using another terminal. So yeah, it's an activated now. So we are learn now. We already create project directories, model images, output. Okay. Now I think virtual environment is created. Also the dependencies has been included. So I think yeah. So everything is installed. So let's start with the first. We will import those two files which is said by the client. Okay. So let's give an instruction that I will add those two files which is shared by the client. One is the image that we need to influence and detect, and other is the .pt model file. Please create folders for those two files so that I will put inside that. So basically, we have given a command that okay, let's create to be in the project structure organically organized. So yeah, so he has created two basically images and models folder. So now we will import those two files basically. So those files are inside downloads, YOLO, and image two. So this is closed now. Okay, so in YOLO.pt, it will go inside the models, move, and this image needs to be renamed as image.png and it will go inside the images. Yeah, so this is the image that client has given. So we need to influence using the YOLO 11 and .pt model with PyTorch. So let's see how it will detect the objects clearly and perfectly. So this is the image and this is the model file. Okay, so place folder YOLO file inside the model, so that we have done. Image folder inside the images, yes, that is also done. The output folder will automatically store pt.result. So basically this result from PyTorch influence, and this is ONNX. Okay. Now at both files, let me exit file name, save Python, configure to use those specific files. Yes, so now I think we are ready to start with the main file. So now everything is on place. Let's create a let's start writing the main.py file. In the py file, please write write the code to load the YOLO 11 and .pt model using ultra and run the inference on the image.png and print the detection results. Do not know ONNX conversion yet, just PyTorch inference. So basically, we are giving the instruction that okay, everything is on plate. Let's start writing the main file. So we are giving the instruction that let's writing the main.py file. Inside that, load the YOLO inner model using the algorithm and the run the inference on the image. Do not create convergence yet because we will go step by step. So first we will create this one, load that model using that PyTorch. We will detect the detection and then we'll go ahead next step. So let's see what what it will write. Also, we are not blindly trusting that code which is written by the AI assistant tool. So we will check that manually, and also we will check using the running manually and into another terminal so that we can also clarify that what is going inside the main.py file. So I think it started writing the files into main.py. So okay, yeah, so it's done, I guess. Would you like me to run inference now? You already placed the file. Would you like to test it yourself first? Yeah, so we will test ourselves first. So he is checking the model file. Okay, so first it will checking the model path. image path, and output path. Okay. Now what is the another things? Okay, so this is the printing YOLO inferences model path. Okay, using YOLO model path is using, and it is using the ultralytics. Okay, then running on the interference in detection result will also printed. Basically, it will showing the getting the boxes coordinations and printing the objects what is detected inside the box. Glass name confidence score. Basically, this is the confidence score. Based on that, it will detect how much clear he is detecting the object. So this is the class ID and class name. So that is also saving the result automatically. Okay. And inside route power the result into the output path. Yeah. So I think it's written the pretty good code. So let's verify using that terminal python python main.py. Okay, let's check how it is resolving. Yeah, we are using the virtual environment right now here. So this is the YOLO interface. Loading YOLO model.11n.pt loaded successfully. Running the inference on that image. Inference is completed. Detection is 5. Okay, so basically it detects the 5 object. One is giraffe. Second is also giraffe. Third is car. Fourth is car. And fifth is a person. So saving result into the outputs.pt. Let's see the output of the image. Yeah, I think it's pretty much good. It is detected to giraffe that is clearly visible. In confidence is 0.95. Car, two cars is also spotted. One person inside the car is also spotted. So yeah, I guess it's done good well. Okay. So I think this is done. So I guess we have imported the YOLO model and using the PyTorch, using this Ultralytics, we have object detection is completed, right? So now let's move on to the next part, which is, convert the YOLO model into YOLO INNX model, .pt model to .ONNX model. Okay. Now PyTorch, now PyTorch inference works. Please extend main.py file by adding ONNX export for ONNX export for YOLO 11 and .pt and save inside the model as dot YOLO 11 and dot onx. So as is per the task, what converted. So I think this one is completed inference with the PyTorch model. Load the YOLO model in PyTorch, run inferences and output results such as boundary box coordination labels, showing the detection. So I think everything is completed for the first step. So now convert the model into ONNX model. So convert the PyTorch model into the ONNX model. So that is the instruction we have given. So let's see how it is working. Okay. So it's thinking and making some changes. Yeah, so he started making the changes in the main.py file. Okay, so I think it's updated the main.py. Okay, updated for addition or an action section. Yeah, so couple of things is returning that newly files. I guess this is for the export model to ONNX. Let's see the main file. Yeah, this is the main file. Print load yellow results. What it is returning updated ONNX export path, added export path to YOLO NNX model. Okay, define that. I guess it returns everything in the one file. So let's give an acceptor. Please separate the function for exporting the ONNX model so that it would be better in code reading. Going ahead, please separate all the functions for different different requirements to match the best coding practice. So I basically it's written everything on the same file, so it sometimes you are not able to get it. So I have given a command that to please separate those functions to convert that ONNX model into the different part so that it would be better into readability so that everyone can understand what is going on and what is if the functions are separated then easy to readable and easy to import anywhere. So let's start making the uh, following the best practices from here only. Yeah. So likewise, so this is the check file exist. So this function will check basically file exist or not. This for is the load OLO model. This is the run PyTorch inference, print detection results, save annotated images, export to ONNX model. Yeah. So this is that export model, and inside the main we will call all the functions that will give the better clarity and better code readability. Yeah, benefit of this respective modularity, reusability, readability, maintainability, everything. Yes. Yeah, so I think it's created. So let's check that model that converting to the ONNX. So where is that function? Load all model, export to ONNX, right? Yeah. So this we are using model.export format is the ONNX so that we are converting dynamic false and simply true, basically simplified the ONNX model. And dynamically false, basically we are saying that input should be the smaller so that it could be more improvement. I guess. Yeah. So I think everything is completed. So let's try it by running that. Okay, let's clear it first. Run the previous command python main.py. So I think it should generate the YOLO yn inside the models folder. Yeah, as you can see, this ONNX model has been converted successfully right over the here. So now we are using this conversion is completed. ONNX export successful and saved inside the this. So all task is completed now. So this is also completed. Convert the model to ONNX model. Now influence the ONNX model. So basically we need to use this converted ONNX model to the same image so that we can get how many differences it will detect. Okay, so again we will go to the cloud console. Now we will give that add ONNX inferences to main.py file using ultralytics. Really, let's say ONNX runtime backend and save the labeled output labeled output inside outputs folder and updated script. So now we are moving on to the third part, which is the inference of the ONNX model. So on the conversion is successful, use ONNX model to run inference on the image again. So let's say what the changes it will make, and then we will run it again. So it should create the another image folder, sorry, image inside the output folder. Basically it will give the, I guess, what is the object detection we will found using the ONNX model. Then we will compare the IOU comparison after that, but let's see what it was generating before that. I think it's taking some time and adding some steps over there. We will validate it once it is done. Updated main file with full ONNX inference functionality. Here is the complete script. So this is the function that is created. Run ONNX inference enhanced YOLO model using .pt and .onnx files. Automatically detects model type, enhance print location and save automatic images. This script performs 7-step load PyTorch model, run PyTorch inference, print this, export to ONNX format, load ONNX model. Yeah, this is the steps we want to complete. So I think it's completely done. So let's see what it is generated. So basically this is the checking file. This is the load YOLO model. This is the run. This is what we have already checked. Yeah, run interference. Okay. So now it is the run inferences image path. So image path is taking from this function. This function is taking the image path from here, and image path is to the run pt models, image file checking images path, right? So we are passing ONNX model over here. So here load YOLO ONNX model path. ONNX model path is taking from the ONNX. So right, it is taking the ONNX updated model from here, pass it into the another function, run on an X model, and using the same image, it will running inferences on the same, right? So I think it's pretty good. It's measured as we have given the previous command that separate all the logics in separate functions. So this is the better performance. We can see that, okay, everything should be in the separate function. So everyone can, understand easily. So let's try to run it again using the previous command. Okay, so ONNX result is also generated, and let's see. Yeah, I think it's pretty much, I think it's both the same, I guess. 95, 95. Car is 90, car is, I think in the PT model, car's confidence is 0.89 and here is zero point 0.9. Person is 0.31, here is also person 31. Second car is 0.85. So I guess pretty much similar result we are getting from the ONNX model as well. Yeah, so I think it is done. Oh, I think it's my battery. It's down. Let me quickly plug into that. Yeah, sorry for the interference. Actually, my battery is going to die. So before that, let's plug in. Yeah, it's done. Yeah. Okay, so I think we have generated the images using ONNX model and .pt model. So I guess let's start the IOU comparison. Let's see how much comparison we will get. So let's move on to the cloud part. So now finally everything is working. We want to do comparison between PyTorch detection with ONNX detections. We want to do IOU comparison. Basically, we want to do IOU comparison between PyTorch detection and with one ONNX detection. So this is the command that it needs to perform. We will say add a new function, add a new function to main.py that compares compares IOU IOU between PyTorch detections and ONNX detections and print mean IOU. Basically, we are taking the median of the both the IOUs, then call that function at last and send full script to check. So basically here we are giving a command of cloud to, let's say, detection is already done within using .pt and .nnx model inference on the same image. Now we are clearing with the IOU. Sorry. So let's see how much we are getting that IOU comparison between that. So I guess pretty much similar results we are getting in both the images. So let's see how much IOU comparison is there. It is taking some time to thinking and generating the code for us. Yeah, I think it's complete. I think it's generated something for us because, but let it complete before. After that, we will check what is generating. Basically, it will changing the logs and all to compare the IOU between those two. It will take some more time. Again, printf. I think it separated the functions and all. Okay, new feature added, calculate IOU. Yeah, so IOU will both the boxes of the PyTorch and the ONNX model, calculate intersection over union. Yeah, basically IOU between two bounding boxes, return IOU value between 0 to 1. So basically, if we are getting the exact one, then it should be a perfect match. But let's see what we will get in the compare detections and all. So let's see the code first, what it is generated then. This is the check. We have checked this one. Run ONNX also. Print detection is also we have checked. Saved the images. Export to NNX. Yeah. So box one and box two. First bounding box and second bounding box. Get the coordinations. Intersection max area. Check if there is an intersection. Otherwise return 0, 0. Calculate the intersection area using inner I x min max, y max min. Calculate an IOU based on divide by union area. If union area greater than 0, else 0.0. Yes, I think this is the correct one. So basically it's comparing the both the detections, but let's check PT results, I guess .pt models, PyTorch result, ONNX results based on that result of ONNX results, PyTorch model, ONNX YOLO model, and IOU threshold equal to zero point 0.5 minimum IOU to consider boxes as matching. So it is running that code printing that boxes, matching the detection, and total PyTorch dissection. Okay, I think it's giving the proper summary that what is the mean of IOU, main, max, and mean. So basically, IOU statistics and what is the detection where that we have got and all. So inside the main paths of all the models and images, functions to run the PyTorch inference, PyTorch generated image, export to ONNX, ONNX inference, then ONNX detection. This is the compare detection, IOU comparison. Yeah, I guess this is the thing that we need to check by running manually. So let's check clear python main.py. Okay, so this is the result for ONNX detection results 5, comparison car match detection match 1, zero PyTorch confidence is 94, but ONNX is 95. Confidence difference is 0.24. So basically, it's giving the summary of that confidence, which is by the comparing of that match IOU PyTorch detection as 5, ONNX detection as 5. Okay, so we are getting that IO mean IOU is 0.96 is I think nearly nearly compared to perfect image. PyTorch inference is on PyTorch model inference is detection of 5 mean IOU is 0.9685. So I guess it's not getting the exact match, but it is getting the 0.96. That is also a good result. And also we can see here couple of persons are sitting inside the car, but that is not detected by the Yono model because it's fall under the confidence criteria threshold, because these Yono models cannot because these persons are behind the glass, I guess. So it will not human eyes can clearly visible that, but models that are using specifically for YOLO 11.8 lightweight model cannot detect those kind of stuff. So I think that is the default behavior we can consider, but still we are getting this good result by comparing this Yono 11x.pt model and .onx model. So yeah, I think it's done from, I think, additional image visualize, compare PyTorch and ONNX. You may include simple IOU comparison to highlight low or two models. You may include simple comparison chart to highlight close due to one. Yeah, so I think this one is, I guess, completed now. So maybe the last one thing we can ask to create a README file for create README me.md file .md file inside this project so that everyone can easily understand about the projects and run by themselves. So basically, I'm asking Cloud to add one README file so that anyone can, apart from me, because I have done this assignment, so I know what the things where it is and what we need to do. So I think README file is required. So I have generating the README file by asking the AI Cloud. So let's see how it's generated so that a evaluator or anyone can be, completely understand what is going on these projects and tasks. Okay, I guess README file is done. YOLO PyTorch versus YOLO inference comparison, a comparison Python Python project that demonstrate YOLO object detection using both PyTorch and ONX runtime with detailed IOU over comparison between true inferences methods. Correct overview features, load the PyNX, generate the automatic component. Yeah, I think it's pretty much clear that it is generating a very good read.md file over here. Yeah, so this is the preview of the MD file. So YOLO comparison features, project structure. So what is it? Is it requirement Python, macOS at least installation CD, Python create virtual environment, activate it, then install the requirements.txt, add your files here. Usage is also explained very well. Output files. Yeah, I think it's pretty much considered everything that we need to do to while creating that if everything we are getting. Yeah, so I think that is it for this task. So basically, thank you.